All right, we're finishing our notes. They took them all. Where's your paper? Get a piece of paper and write it down. There's a drawer over there. You write everything down. And I'm going to have to put you on the H drive for coming to class unprepared. Transmission. The notes we've been doing, we're picking up where we left off. When light passes through matter. Transmission is when light passes through matter. So there's a material and the light hits it and it goes straight through. Another word, blue. Another word or a way that you would see it written would be the word transmit or transmitted, and all of that means the same thing. Those are all light passing straight through. Okay? The amount that the light passes through will determine if the object is transparent, translucent, or opaque. Okay? How much light passes through determines transparent, translucent, and opaque. That's okay. Connor? Aren't you working towards something in your classroom? What's that behavior thing that he has? Your points, boo. We got to keep your points, okay? We got to keep your points. Okay. I'm about to tell you. Okay. The first one is when the matter lets light go through easily. So the light goes basically straight through it. And my image is clear. Okay? That is called transparent. What would maybe be some examples of a transparent material, a transparent matter? Glass. Nope. No, they're not. They're not. Huh? I didn't hear you. What'd you say? Nope. Air. Water. These give you a clear image. Okay, that's the difference here. It's going to be clear. I'll show you in a second what I mean. That's air. Matter that transmits light but also scatters it. Okay, so remember the other day I told you about scattering, right? And what does the light do when it scatters? If I told y'all scatter. Nope. It just like goes all kind of different directions. Yeah, like if I said scatter, y'all would just all run different ways. That's what's gonna happen here. The light's gonna go through, but as it's going through, or after it goes through, yes.
We need Jamie Mueller in the office to check out.
Okay. After it goes through, it goes different directions, okay? So we don't get that clear of an image. Usually our image is going to be fuzzy. Fuzzy image. Okay? So examples of this would be plastic, wax paper, tissue. Wax paper, like when you make cookies and you like put, it's that thin paper, it's not clear. I'm going to show you something that looks like wax paper too. Oh yeah, like after you make hamburger patties and then you put them down and then you put the patty down and then you put the paper on top so they don't all stick. Yeah, that's wax paper. Okay. Another thing would be like your the glass on the shower bathroom door, or how the blocks in the bathroom, like all those blocks make up one square, you know, and it's like if you ever try to look out, you can sort of see, but it's like weird looking. You know what I mean? That is, yeah, it's exactly, but it still lets some light come into the house, into the room. This is called translucent. Translucent. Okay? No, it's not. It's the light is getting scattered, so the image isn't clear. Because remember, to see an object, light has to hit it and light it up. Okay? Finally, the matter that does not transmit any light at all, doesn't let any light go through it, is called opaque. So what would it be? Foil or metal. Wood. Yeah, let's just put stone, and that goes with like brick, concrete, anything like that. You're letting light through. Nope. Nope. Okay, so I'm going to show you real quick what I mean. So you can look and see my circle image on the board, right? Circles are. If I take this transparency and I put it in front of the light, nothing really happens to my circles, do they? Because this lets all of the light pass straight through. Okay, so that's what transparent is. If I take something like this is like wax paper. Here's my circles. What's my image? Fuzzy. But it lets some light go through. With the paper,
so what would paper be since you can see it on
but do you see the glow right there?
Mm-hmm.
So would that be
That's translucent. Okay? I think maybe some construction paper can be opaque, but definitely the regular paper is translucent. And then if you take this, yeah, and then look, there's a shadow. You see the shadow? That's opaque. Okay? So, like the wood, obviously it's not going to go through there. This.
So this goes to install.
What do you think about this?
It's not going to get done.
It's not?
Oh.
It's foam. So there's space.
What about like your hand?
Does that make sense? There's space in between. Okay?
What about like your hand? Like when you do it, doesn't let those like red. It's not
Well, in some places where it's like right in that spot you're talking about,
It's too thick. It's too thick, but like
it's right there. Yeah.
it has to be like very thin.
Yeah. Okay. No, because I'm going to show you something else in a second. Let's go to colors of light. We're going to do this bottom piece first. It was the other page from we got 2 pages at one time. All right. So if you think back to like kindergarten, pre-K times, and you got to finger paint or use the paint brushes and everything, and what would happen whenever you'd mix a bunch of colors together? Black, brown, weird, ugly, right? Okay. That is because markers and paint and colors and all that, they have something called pigment. That's just basically what gives them their color. So we're going to put paint, markers. Yeah, I'm coming. I said it, though. You can write while I talk. So all of those rules that you know for art, and thinking about mixing all colors together and getting like black-brown, that has nothing to do with light. Okay? And the primary colors in art are completely different from the primary colors of light. Okay? So the primary colors of light are red, okay, everybody's going to have to get their colors because there's going to be stuff that you color for a grade. So I don't want to hear I don't have. You can fail it then if that's the case because y'all know from day one you're supposed to have this. Blue, and y'all can color it in way better than me. I'm just hurrying. And green. Red, blue, and green are the primary colors of light.
Why? I thought it was yellow.
That's for pigment and paint and art. But in physics and light, it's this. Oh, yep.
How do you make yellow?
Hang on, I'll tell you. So the primary colors are red, blue, and green. Okay? Where red and green mix, we get yellow. It doesn't in paint. That's what I'm trying to tell you. It's totally different. Red and blue light make magenta. It's not purple. Do not color it purple. It's a pinkish purple. You need to know how to spell all of these too. Blue and green make cyan. It's like a turquoise blue. Oops, wrong color. Okay? And then all colors of light make white. Okay? Think about it. Didn't we learn about the visible spectrum? Visible spectrum, we said, is all of the light that we can see. The sun, a fire, a light bulb. Any light in our world that we can see falls into the visible spectrum. Correct? Okay. Well, what was the visible spectrum made of? Roy G. Biv. So all of the colors smashed together is white.
White is all coming from black is the accent of black.
That is what happens. The proof is the prism. The proof is the rain. The sun already has them all together, and then when the raindrop refracts it, it opens them up into the colors that they're already smashed together as. Yeah, you see it every day. Right now we can see white light. The sun's coming in the window. You can see white light right here on the screen. From the computer screen, from this screen, from that screen, anything. All of those are called white light. If I take, give me that prism. There. I split him. You see it? You see it?
It's like rainbow. It's like
There it is, Connor. Up there above the board. That's what I'm showing him. I don't know if it'll show one on the computer, but... Oh.
Okay, wait, what? Oh, I see it.
It's not going to show it the right way, though. But, so there you go. All white has the colors smashed together. Okay? Yeah, I did purple. Like it's a weird purple, but... And I'm messy today. I don't know why. I know. It's Friday. Okay, so I'm going to use the markers, I think. What did we just learn white light is made of? Okay, so we have Roy. You should be writing. Just draw it as a circle or something. Connor. Yeah, that's what I use for it. If you look on those posters on the wall, you can see between the violet and the other blue, indigo's like this darker. So to be able to do it the right way and make it look correctly, whenever I color it like that, I use like the sky blue for blue. I explained all that the other day. Okay. So, an opaque object. Does an opaque object let light pass through? No. So when white light hits it, we're not going to have anything pass through the object. So we have something like an apple. Is light going to go through an apple? No. So what happens is, white light hits the apple, and since the apple is red, that's the frequency that bounces off and goes to your eyes. All of the other colors of light get absorbed. Green apples? Yep. Whatever shade it is, that's the color that bounces off. So, red is reflected. what were you going to say? I'm about to tell you about that in a second. Stormy, go get me that book. Give me that book right there. That one right there. Yep, hand it to me. Okay, so, the book. Hang on, I'm going to put it back up. White light is hitting the book, right? Because how do we know? We can see the book, so that means light has to hit it and illuminate it. And right here, this darker purple, that frequency is bouncing off of the book and going to your eyes. Whatever frequency of yellow this is, that frequency of yellow is hitting there and bouncing off and going to your eyes. Whatever this orangish red in that spot, that color is bouncing off and going to your eyes. And all of the other colors get absorbed. Okay? Which would explain why after a while the object would start to feel warm if we left it outside in the sun. Does that make sense?
Okay.
Any other questions? Huh? Gray and brown, like gray has some of the same ways of working as white, but it's just like these other frequencies that are picked up or something like that. But if you look it up, they'll say gray works like white and brown works like black, but it's not the exact same thing happening. I'm about to tell you. Okay, so now let's take something like a Sprite bottle. We're going to pretend that this bottle's a Sprite bottle. How do we see the Sprite bottle? Or look, here's a perfect example. I hope that this shows color. There it is. See that right there? How can we see that as green? Because light's going to pass through this, isn't it? Okay, so light passes through the Sprite bottle too. Roy G. Biv hits it. Oops.
But if you put a flashlight, the Sprite bottle, shining on the Sprite bottle, and you look on the other side, the light isn't yellow, it's green because the liquid, the bottle is green.
Yep. And I'm going to do a cool activity with y'all to show this. So Roy G. Biv hits it. Since it's green, green passes through and all of the other colors get absorbed.
What did the eye, why did you draw the,
Just so it looks right. Oh, me, where I'm at. Sorry. Yeah, and I mean, if I use the flashlight, like, you see it? That's the frequency that's going through. It can change the tint, like the shade, because the brightness changes. Yeah, they do change a little bit, yes.
On a summer day, the light, like when you spray your water hose, the light
Yeah.
hits the water and it makes a little.
Yeah, but it takes the white light and opens it up. It takes these beams right here and it opens them up. That's how you see it. Because other than that, they're smashed together. So refraction bends them, and when it bends them all at their different angles, it takes their straight line and does and opens it up, and you can see the colors. Okay? All right, white. So if all of the colors make white, then what happens when Roy G. Biv hits it? Huh? For me, okay, if all of the colors make white, then how am I going to see it as white? What has to happen? They're already smashed together. This is them smashed together as white light. This is one beam of white light hitting a white surface. How do I see it as white? It's because all of them bounce off to my eyes. That was not supposed to curve, but it ended up curving. Sorry. Oh yeah, they bounce off. It's reflection. It's reflection. It's exactly what it is. Yep. There's no such thing as black in color. Black is not a color. So all of the light gets absorbed, yes. Mm-hmm.
Is that why, like, on my cat, is black, like, where all light, like, it's his fur or whatever, the color, it's like a orange color.
I don't know. Think about it. If I talk again about putting you outside in a summer day in a black shirt and making you stand outside in the afternoon, all of the colors, all of those frequencies, all of those wavelengths stay in the object. That's why it gets so hot. Because those frequencies, those waves keep hitting over and over and over, and they make the particles move. Because it's all absorbed. It's all soaked up. And it soaks up the color so that you're left with no color. None. That's why black is not a color in physics.
You
That make sense? Well, I mean, there's certain times that you would want that, you know. That, there's something else in that. I gotta look that one back up. They keep asking me about that again. Okay, on to the lenses.
Oh, we learned about this one convex.
I gotta find another pink. It's like going out. Well, I'm about to use the lenses again. You want one light or one? Put one light on, and I'll just turn it back off in a second. Put one light on. It's just adjusting. Okay. So what do you notice about their two shapes?
One's oval shaped. Yeah, one's like an eye, and then one's like curved in, like paved.
Okay. So convex is the one that is like fat in the middle. And concave is thin in the middle. And it's exactly what he said. Concave caves in. Like that caves in. Okay? I'm still in pink. Okay. The other name for a convex lens is converging. Converge is like all come together. Another name for concave is diverging. That means they all go apart. Okay? The light comes into the lens and bends. I'm going to have trouble drawing this because I didn't draw it right. It bends all to one spot. So all my light is at that dot right there. All of my light bends to one spot. That spot is called the focal point. Okay, so all light is refracted. What is refract? What was our key word for refract? That's why it says to study notes. Y'all don't know my words well enough. What was our key word for refract? bend. Reflect, bounce, refract, bend. So all of the light is bent toward the middle. What do you think if I have all my light in one spot? What do you think is going to happen to my image?
It's just gonna be one.
What do I need to see an object? Light. Light has to hit it. Well, now you have something making all light hit in one exact place. What's the image going to be? Bigger. You focused all the light into one spot.
Oh.
It's going to make the image appear better, bigger.
So that one was just a new theory?
There's got to be some kind of lens or something on there, though.
The glasses, my mom has glasses that the bottom part is the whole bottom is soft and it's like a magnifying one.
I'm not being able to spell right there. Okay, correct. Farsighted. And this is called a real image. It's going to make a real image. Huh? Nope. Nope, prism is not a lens.
So we're talking about like glasses ones?
Okay, if y'all, I can go over the examples right now with you then. That's a magnifying glass. That's why all you little fire people, if you take the magnifying glass and hold it over, it'll end up burning or whatever y'all say, you know, like you can, because it focuses all the light into one exact spot. Okay? Yeah, whatever. Oops. N-O. Binoculars, microscope, eyeglasses.
Does it matter how big the glasses are?
Well, I mean, yeah. Yes, it does. There's other things that are going to go into that, but yes. I don't remember which ones are which. Are you farsighted or nearsighted?
Nearsighted.
Huh? See, I don't know. I get them confused every time and I always get it wrong. So just, you go ask your mom what you are and then you can figure out which one you have. Okay. Concave does the exact opposite. The light comes in and it's bent outward. Oops, I didn't draw it good. I put way too much space over there. And we don't have any light in the middle. No. Now we are refracting away. So what do you think our image is going to be? And they don't use fake image. They just say that the image is not real. Okay, so you know how if you look on one side of the spoon and you can see your face regular, but when you look on the other side of the spoon, you're upside down? Okay, that's convex and concave. Okay, when you're upside down, that's not a real image. Does that make sense? So in these, it's weird. Their focal point is in the front. And so they make an image that's upside down. It can be like upside down, inverted, all this other stuff. We're not going into that. You can just understand the basic. So both of them refract light. And some examples of concave would be a camera lens, a telescope. Telescopes can like use both of them, or I don't know, vice versa. Door peephole. And then eyeglasses. It just depends on what you need. Yep. Turn that light off real fast so I can see if I can do this before we leave. Okay, you see that? You see how it has a donut looking thing, like there's a light in the middle? That's convex. It puts all the light in the middle. Look at this one. You see how there's a shadow in the middle? That's concave. All of the light gets bent to the outside, so it makes that halo looking thing on the outside. Yeah. Does that make sense? So light on the outside, light on the inside. Got it? Awesome.